So here's an example where we're given a circuit, and then the circuit feeds into this arbitrary box here that they're calling it. And we see that the circuit feeding it has this switch. And for t less than 5, the switch is closed. But then for t greater than 5, the switch is open. And so they're telling us when the switch is closed that our box absorbs 150 watts. But when the switch is open, the box absorbs 65 watts. So, we need to calculate what value of Rx is required for the 65 watts. So we recall when we talk about power then that is voltage times current. So in this case, we see that we have a current source here. So it's pumping 3 amps into here, constant. Now, those 3 amps can split up different ways here, but when it comes back out here again before it goes in the box, it still must be 3 amps because we have to conserve current. So that being the case, this is a constant, so it will not change. So if our power is varying, the only way that can happen is if our voltage is varying. So that means we must have a dependent voltage source. So we could draw that then. We'll say we'll have some internal resistance here, and then we will have this dependent voltage source inside of here. And so the only thing that it could be dependent on then is the only thing that changes is what the voltage is between node 1 and node 2. So we'll call that V12. So there's going to be some constant. We'll just arbitrarily call it H. You could call it A, B, C, D. It doesn't matter. So it's some value H times V12. All right, so then as the switch opens and closes, that voltage will change, which will make this variable voltage change and change the power absorbed. And so we'll call this resistor here then RB for our box. So we also recall then that we can utilize Ohm's law with this equation, and so we can substitute in for the V. So V here we know is equal to I times R. So when we do that, that'll just be P power is equal to I times R times I again. So that's going to be I squared R. And so in this case, we know the power and we know the current. So now we can solve for R. When we do that, R is equal to P, the power, over I squared. So in this case, and again, this is for T less than 5. When the switch is closed, we know that that's 150 watts over 3 squared because the current's constant. And so when we calculate that out, that is 16.67 ohms. So that is the value of this resistor right here. Okay, so now we want to look at, again, this is for T less than 5. So now we want to look at for when T is greater than 5. So when T is greater than 5, the switch is open. And we know now then that the voltage 1, 2, before it was 0 because it was just a short circuit, but now the difference between 1 and 2 goes through here. And so it's going to be equal to IR. And we know I is 3 amps, but we don't know R. So we'll keep that in our back pocket. We also know that the power for T less than 5 is 150, and then the power for T greater than 5, which this is given right here, is equal to 65 watts. And so the difference in those, so P T less than 5 minus P t greater than 5. That'll be 150 minus 65 is equal to 85 watts. So this is what the voltage source must supply to give us that difference. So again, we recall that power is equal to voltage times current. And so in this case, we know that the voltage is going to be this voltage times the multiplier. And so that's going to be times the current. So the current is 3, and then that's going to be H times V12. So that's going to be 3 times H times 3R. And so I get that from right here. And so that's going to equal to 9 times H times R. And that has to equal to this difference here of 85. So there's our equation that describes our relationship there. So it's one equation with two unknowns. So there are actually multiple answers. It boils down to then that our relationship between H and R should be equal to 85 over 9. Okay, 85 over 9. So that's the ratio that that must maintain, and so that's equal to 9.44. So if we took, for example, then that H was equal to 3, you had a multiplier of 3 on your dependent source here, we could calculate what R would have to be to satisfy these power requirements for the switch open and close. R then is going to be equal to 9.444 divided by 3. Again, that's just solving this equation here for R. And when we calculate that, we get that R must be 3.15 ohms. So this is a little bit different problem. It's kind of relating power to a variable voltage source, but this is how this works.